Hello everyone, I'm Tasneem and my topic for the presentation is Context-Aware QoS Prediction for Web Services using Deep Learning. This is the outline of my presentation. We know that the number of mobile and IoT devices have increased greatly, and as a result, the number of web services have also increased. However, since the number of services have increased, it is hard to select a service that is most suitable for the user. In order to choose the best service, the properties of services are to be analyzed. They are classified as functional and non-functional properties, and QoS or quality of service is a non-functional property. It reflects the degree to which services offered by providers satisfy the requirements of users. It helps to manage the system capabilities in order to provide IoT services. QoS prediction is essential for performing service recommendation and selection in mobile and IoT environments. Collaborative filtering has been a popular method for performing QoS prediction. Collaborative filtering or CF predicts user interests by studying the user preferences. Therefore, there is collaboration between users. For effective QoS prediction, contextual information can be utilized. Contextual information is information that gives context to a person or event. Coming to the related work, so literature study has been done on the various collaborative filtering techniques. The two most popular CF techniques are neighborhood-based and model-based CF. Neighborhood-based CF is again classified as user-based, service-based, and hybrid CF. Neighborhood-based CF, so this technique uses the behavior of other users to know what the current user might like. Coming to user-based CF, it makes suggestions by considering users that have similar interests. So the rating information from the ratings given by similar users are used for making predictions. Next is service-based CF. For accurate service recommendations, CF-based systems that consider the preference of users are required. So service-based techniques, also known as item-based CF techniques, use past user experiences of users to make predictions. In hybrid CF, both the user-based and service-based techniques are combined for performing QoS prediction. It uses the QoS information historically invoked from users and services. Next is model-based CF. These techniques operate by constructing a model based on the rating information. Matrix factorization is one such method where data is taken from dataset and then it is built as a model which makes the recommendation. Later, techniques based on neural networks were introduced. They could learn arbitrary functions from data. For this, it uses a neural architecture. After completing the literature survey, there are some of the limitations that are identified from the existing techniques. These are cold start problem. This problem arises for newly added items. It refers to providing suggestions to users having no preference towards any item. So items may not be recommended until someone rates them. Data sparsity is another issue where each user only gives ratings for few items. There is a need for greater accuracy for prediction tasks. Also, newer deep learning algorithms can be utilized for QoS prediction. Finally, scalability is an issue, especially for large data sets. So this is the proposed system for QoS prediction of web services. Fuzzy C-means clustering algorithm is used to cluster users and services using their contextual information. After performing FCM clustering, similar user clusters and similar service clusters are obtained. So this contextual information, along with the historical QoS information, is used for performing the prediction task. Here, LSTM or long short-term memory networks, BiLSTM or bidirectional LSTM, CNN, convolutional neural networks, and GRU, gated recurrent unit network, algorithms are used for performing the prediction task. The performance of these algorithms are then compared in order to find the better algorithm for performing the prediction task. So the first step is data preprocessing. Here 4 matrix files from the WSDream dataset are utilized. The computing environment used is MATLAB. So the 4 matrix files used are user list, which contains the details of 339 users, service list, which contains the information of 5,825 services, response time matrix, which is a 339 into 5825 user item interaction matrix in terms of response time, and throughput matrix 339 into 5825 user item matrix in terms of throughput. Fuzzy C-means clustering or FCM algorithm. It allows each data point to belong to one or more clusters. So each data point can belong to one or more clusters with various degrees of membership. In order to achieve this, the probability of that point to that cluster is calculated. The advantage of using FCM algorithm is that it can cluster boundary objects more effectively. Coming to the parameter selection, in order to select the number of clusters, minimum centroid distance is used as a validation index, and the fuzziness parameter m is set to 2. Coming to the training data preparation, only some records from the dataset form the training set, and the rest of the records form the test set. So here, training sets with various data densities such as 1 to 5%, 10, 15, and 20% is used. This is done in order to simulate the real-world scenario where data records are sparse. The experiment is repeated for each case, and the mean absolute error and root mean square error matrices are calculated for each of the experiment. The first deep learning algorithm used is the LSTM network. It is a type of recurrent neural network that can learn dependencies from sequential data. Its network state contains information learned from the past. This network is composed of 4 layers: sequence input layer, LSTM layer, fully connected layer, and the regression output layer. Coming to the bi-LSTM network, it combines the bidirectional RNN and LSTM units in order to study the contextual information. It consists of 2 LSTMs, one in the forward direction and the other backwards. These networks increase the amount of data available to the network. Convolutional neural networks, or CNN, it mainly consists of convolution and pooling layers and one or more fully connected layers that follow the previous layers. This is the CNN layer architecture used. Here the primary layers are convolution, ReLU, and pooling. So there's an input layer, output layer, and many hidden layers in between. GIU networks. It is a more advanced version of the recurrent neural network. These networks can learn long-term dependencies between time steps in sequence data. It uses gates to control the flow of information, and these networks are faster to train. After utilizing the deep learning algorithms for performing the prediction, the performance of these algorithms is evaluated in terms of both response time and throughput properties. The parameters used for evaluation are mean absolute error and root mean square error. So these are the formulas used for calculating the mean absolute error and root mean square error. Here yi refers to the actual value, yp denotes the predicted value, and n refers to the number of observations. The comparison results are given in table 1, 2, 3, and 4 given below. This is the obtained result in terms of response time property. Here the densities of training sets are 1, 2, 3, and 4%. These are the results in terms of response time property for training data densities of 5, 10, 15, and 20%. This is the obtained result in terms of throughput property for training set densities of 1, 2, 3, and 4%. And these are the results in terms of throughput property for training set densities of 5, 10, 15, and 20%. It is evident that under response time property, LSTM performed the best, followed by bi-LSTM. In terms of throughput prediction, CNN and bi-LSTM give good performance since the error values are minimal. Coming to the conclusion, so here various QoS prediction techniques using 4 deep learning algorithms, CNN, LSTM, bi-LSTM, and GIU has been used for prediction. And prediction is performed in terms of response time and throughput properties. And the mean absolute error and root mean square error has been calculated for various training data densities. Experimental results have shown that LSTM performs the best in terms of response time prediction, followed by bi-LSTM. Under throughput property, bi-LSTM and CNN give good performance. So it may be concluded that bi-LSTM is the most optimal algorithm for performing QoS prediction. Although bi-LSTM is the preferred algorithm, this algorithm is slower during training, whereas GIU is a much faster algorithm. But the error values produced by GIU are not very optimal. So all these algorithms can be utilized for performing QoS prediction effectively, since the error values are minimal. In the future, other factors affecting the QoS values can be considered, and their impact may be studied for performing QoS prediction. These are the references. Thank you.